Hello everyone. Today we are going to discuss what is homogeneous equation based on degree, also how to solve homogeneous equation. So this homogeneous equation does not mean the same as linear first order differential equations dy dx ex y equals to g of x, where the function of independent variable means source term 0 means we call homogeneous equation, but here this homogeneous equation does not mean the same things. So first I want to define what is homogeneous function. If a function f holds the property when we put x equals to tx, y equals to ty, after that when we get the result same as t power alpha function of xy, then we call this function is homogeneous function with degree alpha. Like say when we have given a function xy, we call this function is homogeneous. When we put x equals to tx, y equals to ty, then we get the new function xt yt is equals to t power alpha function of xy. That means when we put x equals to tx, y equals to ty, we get the same function but times with t power alpha. Then we call this is homogeneous function with this alpha. Here alpha is any real number. So now we define what is homogeneous differential equations. So let us consider these differential equations. You can see here m is the coefficients of dx. It can be function of xy. Also the coefficients of dy we consider n. This is also function of xy. So this is not the standard form of equations. The same equation we also can write this way. This is also not the standard form of equations. Without any calculation, we can say this is a homogeneous function if we see that here m is second degree or any degree, all the terms of m are same degree. Similarly, all the terms of n are the same degree, then we call this is homogeneous function of same degree. That means we have to make sure that this m and this n are homogeneous function with same degree, then we call this is a homogeneous differential equations. So let us consider an example. Here I considered an example, say given x square plus y square dx plus x square minus xy dy is equals to 0. So this is the differential equations, but this is not the standard form. So let us consider this is m, this is n. That means we consider coefficient of dx is m, coefficients of dy is n. So we get mxy equals to x square plus y square, nxy is equals to x square minus xy. Now we put x equals to tx, y equals to ty in m. Also we put x equals to tx, y equals to ty in n. When we get the same degree functions, then we call this is a homogeneous equation of same degree. So first we have to make sure this m is homogeneous function. So if we put x equals to tx, y equal to ty, then we have to get this answer. Here this is alpha is 2 xy. Now you can see how we get this answer. We put x equals to tx, y equals to ty in m, then we get tx whole square plus ty whole square. After that we get t square x square plus y square. That means we can write this one t square mxy, because x square plus y square is equal to mxy. Similarly, we put x equals to tx, y equals to ty in n. Then we get tx whole square minus tx ty. After simplification, we get t square x square minus t square xy. When we take common t square, we get x square minus xy. Here you can see that this x square minus y square same as our n. That means we can say t square nxy. So that means according to the definition, we get n tx ty equals to t square nxy, m tx ty equals to t square mxy. So we can say that m and n both are homogeneous function with degree 2. Therefore, we can say this differential equation is also a homogeneous equation. Homogeneous differential equation with degree 2. So let us solve this homogeneous differential equation. To solve this homogeneous differential equation, we have to put y equal to ux. Similarly, if you want, you can put x equals to uy. So you will get the same answer. So here we put y equal to ux, then we get u equals to y by x. So when we differentiate this one, dy equals to u dx plus x du. Here u is our new variable instead of y. That's why we have to use product rule for these derivatives. Now we put y equal to ux and dy equals to x du plus u dx in the given equations. So we get this equation when we put here y equals to ux, so y square is equal to u square x square. Similarly here we put y equal to ux, then we get x square u. After that we take common x square from here, also from here. Then we get 1 plus u square dx. Here we get 1 minus u x du plus u dx. Now we divide this equation by x squared, so the x squared will cancel. Then we get 1 plus u square dx. Here we get 1 minus u x du plus u dx. Now we can simplify this part. So we multiply 1 minus u by this term u dx. Similarly, we multiply 1 minus u by these terms. After simplification, we get this one. So here this u square, this u square is cancelled. So we can say 1 plus u dx. Here we get 1 minus u x du. Now our target to make this equation as like say function 1 dx plus function 2 du. Here f1 can be function of xu, f2 also can be function of xu. This can be x and u. This one also can be xu. So when we rewrite this equation, we get 1 plus u dx plus 1 minus u x du. Now our target to make it dx, we have to bring x one side, y another side. That means we use separation of variable. Here we use separation of variable. Then we get dx by x plus 1 minus u divided by 1 plus u. After that, I show you the simplification here. How can we get these terms from this? So from here we get this one. Here I show you how to get from here to here. 1 minus u, 1 plus u, we can write 2 minus 1 plus u. When we simplify this one, we'll get same 1 minus u. Now we can write as two terms, 2 by 1 plus u minus 1 plus u by 1 plus u. Then this 1 plus u by 1 plus u become 1, so we get 2 by 1 plus u minus 1. Then it's easy for us to integrate. So then you can see when we integrate, we get these terms. You can see here, when we integrate this one, we get this one ln x. Here we get this one u, we get this one 2 ln 1 plus u. So this is equals to integrating constant. You can write c1 or you can write ln c. It's up to you. When we write, normally we have to write ln c like this, because ln is undefined for negative value. So finally we get this one ln x minus u plus 2 ln 1 plus u. Here ln c. Here I use absolute value because of ln. Ln is undefined for negative value. That's why we use here absolute value. Now we can keep ln x, ln 1 plus 2 u, ln 1c in one side. Then I bring minus y by x in another side. Then we get here, now we can see here ln x minus y by x plus 2 ln 1 plus y by x is equals to ln c. So we can keep y by x in left side. Then we can bring ln c in this side. So we get ln x plus ln 1 plus y by x whole square minus ln c. So you know that ln b is equals to ln a plus ln b. Then minus ln c means ln ab by c. So we write here ln ab by c. So this one, when we simplify, we can write x square x plus y whole square. Now this x and this x cancel, so we get x c x plus y whole square. So this is our obtained answer.